Welcome to Dr. Anima Upadhyay's YouTube channel. And as you all know, I have started a new series on chemistry and technology, in which I have already posted one video about matter, elements, compounds, and mixture. So, this video is in continuation with the previous video. If you have not watched that video, please do watch it. In that video, I have explained you that everything in the universe is made up of matter. Be it us, the human beings, trees, plants, soil, planets, stars, everything is made up of matter. Matter in turn is made up of elements, and elements are defined as the pure substances which are made up of similar kind of atom or atoms, and each atom of an element have identical number of protons in their nuclei. The various examples of elements are carbon, hydrogen, nitrogen, gold, copper, silver. So everything is made up of atoms. That is the basic unit of matter. Even we are made up of atoms. So today we will discuss about the structure of atoms. But before I start my video, I'll remind you to please subscribe my channel and also like and share my videos. So let us start with the structure of atom. An atom is very tiny and it cannot be seen by the naked eye. But it is made up of subatomic particles called electrons, protons, and neutrons. Every atom has a nucleus in the center, and the negatively charged particles called the electrons revolve around the nucleus in their fixed orbits. The number of protons in the nucleus is same as the number of electrons that revolve around the nucleus. And this is the reason an atom as a whole is electrically neutral, because the number of negative charges around the nucleus is exactly the same as the number of positive charge in the form of protons inside the nucleus. But a question may come to your mind: why the electrons keep revolving around the nucleus and don't leave the atom? It is because of a very strong force that acts between the protons and electrons that holds back the electrons in their orbits. And this force is called electromagnetic force. But then same force can remove the protons from the nucleus, because they are all like charges present in the nucleus. You can ask this question to me. Now here comes the role of neutrons. Neutrons are also present in the nucleus and they are not charged. They are neutral. So these particles, neutrons and protons, they exist together in the nucleus, and there is a force which is even stronger than the electromagnetic force, which holds back the neutrons and protons together in the nucleus. So this is the reason. To remove an electron from the atom is very difficult. But to remove a proton from the nucleus is even more difficult than removing an electron from its orbit. Now, as I said, that the number of protons is same as the number of electrons orbiting around the nucleus. And it is the number of protons which is also the atomic number of an element. So, the number of protons is called atomic number. If there is one proton in the nucleus, its atomic number is 1. If there are 2 protons in the nucleus of an element, the atomic number of that element is 2, and so on. And it is denoted by the symbol capital Z or Z. The number of protons and number of neutrons together, that is the sum of number of protons and neutrons, is called the mass number. Now this number of neutrons in the nucleus can vary. It is not necessary that an atom should have the same number of neutrons as the number of protons present in the nucleus. And this gives rise to isotopes. So what are isotopes? Isotopes of an element are the atoms having the same atomic number but different mass number. That is, the number of protons in the nucleus is same, but the number of neutrons varies. And it depends upon how many neutrons can fit in the nucleus. I'll give the example of hydrogen and its isotopes. So in a hydrogen atom, the number of protons in the nucleus is 1 and only 1 electron revolves around it. But if in the same hydrogen atom, besides 1 proton, 1 neutron also exists, then it becomes deuterium. And if there are 2 neutrons besides 1 proton, then it becomes tritium. So these are the 3 various isotopes of hydrogen. No neutron, hydrogen. 1 neutron and 1 proton, deuterium. 2 neutrons and 1 proton, tritium. There are isotopes of other elements also, like carbon has isotopes, iodine has isotopes, nitrogen has isotopes. So you can list down the various elements and their isotopes and look for their atomic and mass number. All the isotopes of the same element are placed in the same place in the periodic table because they have same number of protons. Therefore, their chemical properties are same, but their physical properties differ. Now, these isotopes can be naturally occurring isotope or could be artificially made isotopes. They could be stable isotopes or they could be unstable isotopes. The stable isotopes are fine, but instability is because of too many neutrons present in the nucleus, which gives rise to a very huge, enormous energy inside the nucleus that makes it unstable. And it starts emitting radiations in the form of alpha, beta, and gamma rays so that they can come to the stable state. And these isotopes are called radioisotopes. They have many applications in medical and engineering fields. So we will be talking about radioactivity in my future videos. Today I will stop here. How to split the atom, how to remove the electrons and protons from the atom, we will be learning in my next video. Till then, take care of yourself. Keep watching.